I'm Maximilien. I go by Max, and this is my colleague James from Pivotal.
Hello.
And today we're going to talk about comparison of PaaS 2014, and I'll explain to you why it's 2014. And also, it feels a lot like this. You know, James and I, when we were doing this, we were trying to figure out a way to kind of compare different PaaS because obviously it's a topic of interest. I don't think all of you are here to just see James and I. And it sort of feels like this, right? Because you're sort of comparing two things that are not necessarily equal, but then you feel like they should be. So let's jump into it and see what we have. So very briefly, the agenda is going to be split between James and I, but I'll start and then he'll take over and get you to the end. But basically, I'll give you an idea of what the background of this, where it started, this whole idea of trying to compare the PaaS, and also the methodology, because I think that's important. I came from a research background, and I'm keen to making sure that you understand the limitations of this. Then James is going to take you to some of the insights and also a really cool quality of experience test case that he did for this, and then also potential next steps. So first thing is that I was working at IBM Research for a long time before getting this new job with working for Angel and Alex. So this is based on initial research that we tried to do in 2010, when cloud and certainly PaaS were very new. And part of the idea is to try to compare them to not only make decisions, but also to improve different other PaaS that we have. And of course, today, what you see is the PaaS that we sort of see are the leading ones. And of course, Cloud Foundry is part of it. But the rest that you're going to see are things like Microsoft Azure, Google App Engine, which got sort of ramped up recently, and AWS, but specifically Beanstalk, and of course the services that are around it, Heroku and OpenShift. And it significantly was revised with Pivotal's help and certainly James this year. So first thing is, what are the limitations? Because this is important. Coming from a scientific background, I want to tell you that this is not a scientific comparison. But there's value to it, and maybe we can make it more scientific, but it's not scientific. But what does it try to do? So of course, what are the challenges, right? So if you think you're going to compare PaaS, a lot of it is trying to not only compare features that you see, but also features that people advertise. And a lot of time, the reality may not match what's being advertised. There is no way to just have a measuring stick and in every feature you just measure it, right? So it's a little bit more subjective. And then you get the signal and noise problem. So you're measuring a lot of things on the internet. Unless you have a fair amount of statistical sampling, it's going to be very hard to differentiate the two. So there is significant challenge when you try to compare things that are on the web. So this approach that we took, the method that we took, is not scientific. So very important that you understand this. And it's potentially biased also. Obviously, James and I are working, he works at Pivotal, I work at IBM, and we're all deep into Cloud Foundry. So we are certainly, to some extent, biased. However, we tried to be as much as we could objective, and hopefully that will show. And then finally, the real value is in providing potentially what could be a framework so that you can do your own analysis. And maybe as a group, we can also do an analysis that would be valuable. So another aspect also is to measure the quality of experience, which means as a developer, if you put yourself in a shoe of developer, if you're not developing, what is the experience when you try to use a particular PaaS? And I think James is going to take us through what he did doing exactly this test case. So first thing is, what's the overview of the comparison? So first thing, we scaled from something like 35 different features when we first did this at IBM to about 50 with James helps. And what we did also is to divide those 50 different feature points into 8 groups. And the groups are things like workloads, tooling, so we kind of group the different features for each one of those groups together. And then integration service, SLAs, datastores, programming model, management, and miscellaneous. So things that don't fit, you just kind of group them together. And then another thing we did is if there was a feature that was supported all across the board, we kind of removed it because it's sort of assumed. And then in some cases, if it wasn't supported at all, then we removed it because it's just quite not there yet. And some features are kind of in the middle. And of course, how do we measure it? Where we ask the question, to what extent for that particular feature, a particular PaaS supports it? And of course, to answer that question, it's based on experience, based on what we read from the web, and then what we can try. And we have 4 values. 0 meaning that that feature is not supported at all. 1 is that it's a basic support for it. 2 is that it has strong support for it. And then 3, it's a leader. So it's not only strong, but it's also leading the space, the PaaS space. All right, so without further ado, let's go through the first group. So first group is workload and tooling. What you see is kind of a map, and the highlights are the parts where the feature is highly supported, and then the lighter shade is where it's not supported. And from there, one of the things that you can see is that Web 2.0 has a workload. So we found like analytics workload, transaction workload, media, Web 2.0, mobile seems to be across the board, which you sort of expect, but mobile is increasing. Another thing that you can kind of see from this is that the open source clouds, which is the first 3 groups, so the first groups on the top are the open source, and at the bottom are the proprietary ones. You can see that they have very strong support for tooling, at least from our experience. The next group is integration services and SLA. This is an area where we think, and we try to be, so I see people like Chris pointing me, hey, why did you rank me 3 or something, or 2? I mean, we try to be as much as we could objective. I mean, James, I know, corrected me a few times when I gave Cloud Foundry more credit than I should, so we scaled it down to make sure that we were trying to be objective as much as we could. But here in SLA, this is an area of research, at least when I was in IBM research, I was interested in. So things, for instance, like, does the cloud give you credit if it goes down and if it advertises 7 nines? Well, it turns out Amazon and Microsoft are the only one doing this right now. So they actually advertise a certain availability, and they will credit you.
And Google.
And Google also does that too. To some extent less, but they do it. We don't do it yet. I mean, so maybe that's a place for improvement. So the idea is that I was trying to find colors where the highlights, the heat of the map, so the 3s and the 0s are highlighted, but also integration services have a set of colors versus SLA guaranteed has another set of colors. And you can see in the SLA guaranteed, there's a fair amount of 3s because people are essentially supporting a lot of those features. Those are the kind of features that when you go to a PaaS, you want, right? Availability and so on. Okay, moving along, because I want to make sure James has time to cover his test scenario, his data store and programming model. So this is an area where open source PaaS is certainly very, very strong. I mean, Cloud Foundry is certainly a leader there, Heroku as well, where they support multiple frameworks and multiple languages. And then AWS has a very strong maturity model when it comes to something like supporting different kinds of databases. Now, because a lot of the PaaS have marketplaces where you can add a service to add a database, this could also mean that eventually a lot of these becomes no differentiators because different services will be available. All right, 2 more. Management. This is, of course, very important for PaaS. As a PaaS user, what you're looking for is a system that can sort of auto-manage, self-manage itself. And this is an area where auto-scaling maybe eventually when it starts becoming supported. Of course, you know, to what extent, that's the question. Most of the PaaS support some amount of that right now. You know, OpenShift has announced a lot of features around this, so that's great for them. And then also, when you look at monitoring, most of the PaaS essentially allow you to hook up to a paid monitoring service. Okay, the final slide for me is sort of a grab all, so miscellaneous where things fit. Clearly, the open source PaaS are strong when it comes to open features, as you would expect. And AWS and Azure, very strong when it comes to supporting integration with backup and load balancing and things of that nature. So with that, let me switch over to pass it to my colleague James, and he's going to talk to you about his quality of experience.
Thanks, Max.
Sure.
So this was a kind of an interesting idea when Max had approached me about the talk, because my intuition was to approach this from a user experience. And Max had this great matrix that he had done years ago and basically refreshed it for 2014. But the approach I took was, there's a lot of different slices and dices, but what does it feel like subjectively to take a scenario that's popular and use the platform? So that's what I did. And we learned something recently. Ben Hale, who did the Java Build Pack talk earlier today, he did some analysis against our publicly run Pivotal Web Services, which we call Run Pivotal IO also sometimes. And we looked at all the applications that we have in there that when you push an application to the platform, the build pack tells you what kind of build pack it is. It's a Java, it's a Ruby, Node, whatever. And it saves it in the database. So we gave Ben a database dump, and we said, hey, Ben, figure out what kind of applications people are pushing to our platform. And it turns out that somewhere around 60–70% of the applications are Java applications. And a lot of them use relational database. So that's a scenario I picked. As a Java developer, what's it like for me, a day in the life, to use one of these platforms, push an application there, scale it, update it? What does that look like? What if I have a problem with my app? Does it heal itself? Those are the kinds of situations that I wanted to put myself through in just like a day-to-day situation. So we looked at OpenShift. I used OpenShift Online. I used Heroku, Amazon Beanstalk, and a couple other services like RDS to go along with that. Google App Engine and Cloud Storage, or Google Cloud SQL, which you gave a 0, so you had a little mistake there.
Okay, perfect.
This should probably be a 3. And Microsoft Azure. And those, I evaluated 4.5 of those. I didn't quite finish Azure, but I got a pretty good idea. And then Cloud Foundry as well, running on Pivotal Web Services. So let's take a look at each one of those. So with Beanstalk, it is incredibly well integrated with all of their micro features. I think a lot of people realize this when you see the birthday cake diagrams of EC2 and S3 that they started with, and all of a sudden they added RDS. They added Elastic Load Balancer there. They added S3, Dynamo. They put all these things together. When you use something like Beanstalk, it's automating a lot of those things together. They hook in things like the metrics and monitoring with simple notification services. They have auto-scaling groups there. So it really reduces the IaaS friction. If you just show up on Amazon, you're going to be pretty overwhelmed. But if you've never used it before, but if you show up at Beanstalk, it's pretty straightforward. Even as a Java developer, you can show up with your WAR file and get going. And they have incredible out-of-the-box monitoring. You get these beautiful charts and graphs just right away out of the box. What they didn't do so well is responsiveness. They were by far the slowest platform. It took me about 15 minutes to spin up my application with one container, or one VM and a database. So that stood out. It didn't really feel like the other platforms. They treat different frameworks different ways. So when you use Node.js, it feels different than when you're using Java, because I think you check things in with Git, and with Java you upload WAR files. So it's like, it doesn't really feel like it's the same platform when you're using different languages. You have to understand, even though they hide as many as you can, they try and wizardize a lot of things, you have to understand a lot of AWS concepts. And the extensibility of the platform it's very closed. Google App Engine, they did a really nice job, just like Amazon, of really deeply integrating in with all of their other services. So really nice load balancing, really nice Cloud SQL integration, and they have, even better than Amazon, integration into their web services. So when they do things like, if you want to do searches and maps and things that where you have to pay as a developer to use these features of Google, they've made that first-class integration in with Google App Engine. They have really nice events and runtimes. What they didn't do very well, and this is one of the first PaaSes I ever tried, way back when they first announced it. I became frustrated that they took away some things from me as a Java developer. I couldn't have my own threads. I couldn't use a relational database. That was when they first came out. And they've taken away a lot of those restrictions. But even in reviewing this documentation the last few days, they still, like for example, want you to use their Google SQL driver. And you have to insert the database connection yourself manually in your code about where that database is. So they still have some kind of nuances that take away things from a normal Java experience from a Java developer. you can't really customize the container too well, and you weren't able to debug it. Those were some things that were frustrating. Azure was the one I didn't get to finish all the way, but they had a lot of options for frameworks. They did a really nice job in their web experience and getting you started. It felt a little bit more like a virtual machine kind of orchestration on their websites. That was their quick getting started option. And they're deploying to Windows, which is different, not quite what I expected. I mean, you should say maybe I'm naive, but I've been hearing all this marketing from Microsoft about how, no, this is a general IaaS, but then they push you onto Windows right away. And I was expecting to be able to have that be more of a default option. The SCM integrations were best in class, by far the best I'd seen for being able to onboard an app. You could do all kinds of things like send it to Dropbox. So you could all kinds of different options for getting the app onto the platform. OpenShift, they're pretty interesting because they're the ones that's most often compared with Cloud Foundry because we're both launched around the same time. We're both open source. And the thing I found about OpenShift that I really liked, they had best in class by far of any of the other ones as well that I've looked at. The SSH and port forwarding features were just really nice because I could go directly into the container right away and see problems. I could port forward things onto my local virtual machine just with one command. So I could just attach a debugger or send traffic to the remote containers really easily. Having SCM and CI directly integrated were pretty nice capabilities, but there's a lot of not so well things I didn't like about OpenShift trying it from a user experience. A lot of things were out of date. It defaulted to Java 6, for example. The versions of things were old. I found it hard and confusing to choose which cartridge to use because unlike Cloud Foundry that does auto detection, you have to be explicit about what cartridge you want the platform to run. And there's a lot of options to choose from even within the Java ecosystem between Tomcat, this version of Tomcat, that version of Tomcat, JBoss 6, Wildfly, JBoss 7. So choosing the right one became kind of overwhelming and a little confusing. Didn't have some things that I would expect for health management and killing an application. It didn't come back. So you're forced to manage that yourself, your own availability. Scaling up only happened one instance at a time. So like the scaling scenario I used, I say scale up to 5 instances of my application. I couldn't do that without doing it one at a time, and it took about 2 minutes to get there. In doing a netstat -a, you see all the host traffic for all the other containers on that host, which I found really kind of disconcerting if I wanted to be secure on my platform and knowing that other people could see my network traffic, or at least my source and destination. And the WAR file support was limited there as well. I think Heroku has absolutely the best user experience from the tool chain they put together in terms of just the polish around not only their web presence and then also their documentation and the way they document the APIs and then the way they put the CLI commands together. They have some features that the other people don't have for things like the Heroku run command, pipelines, stats and logs. The marketplace is really well filled out. And they just use some other really nice things. So like when you update your application, you restart it, you're going to have a brief amount of downtime typically if you're going to kill your application. And they know that your application's restarting, and they'll hold inbound requests at the router waiting for your app to come back up again. It's a really nice user feature that you get for free on their platform. And they do things like unpausing your app for you and hold the request at the router. Java just seems like a second or third class citizen at Heroku. The things that they were out of date, they didn't really have WAR support built in as a default. I heard from Romney Voss that they have a plugin that you can use if you're willing to use Java 6, but that's not really something that people want to do anymore. You have to use Git, so you don't get to use other choices there. And their team support is pretty limited compared to the other platforms. So what did Cloud Foundry do well in this kind of test? I really found, and I was kind of surprised to find this, that the Java support in Cloud Foundry is absolutely best in class. And you can kind of see this from the containers that we support. It all really starts with the Java build pack having such excellent support. So everything, whether it's the JDK, whether it's the version of Tomcat that's in there, or all the dependencies that Ben was listing earlier, they're all updated almost every single week. And that's incredible because as a developer, you're always getting the modern stuff you're doing. Some of these other platforms, I had to downgrade the version of Maven I was using because they're only on Maven 3.0 and there's things down from Maven 3.2. And Cloud Foundry really scaled and responded quickly compared to some of the other platforms that I was using. The logs were definitely a big strength. Log Aggregator made a big difference when it was introduced about 6 or 7 months ago. Probably 8, 9 months ago is when it got kind of introduced, and then stronger over the following months. And now 6 months later, I just take it for granted. But when you use these other platforms, you don't see that a lot. A lot of them want you to SSH in to every single container and pull the log files out individually. That's really a pain. And the way that Cloud Foundry deals with services is so elegant compared to these other platforms. Like, I was just shocked that Google made me go find my database URL and construct it, manually insert it into my code, and instead of giving me an environment variable. That just seems so strange to me after using Cloud Foundry services. Things that we need to work on after doing this tour, I really feel like, hey, I get jealous. Like, that platform has that feature, I want it. As a user, we need to make it better to have shell access to the containers to be able to look inside, see what's going on. There are some workarounds you can do. We talked about them on VCAP Dev in the last couple of weeks to do things like a tmux session with this thing called Teammate. The spirit of that kind of capability of being able to shell in is something we definitely need to do. And have much better SCM and CI integrations that we do baked into the platform. We certainly use it that way. When we're building Cloud Foundry, we put things into a CI pipeline that starts with source control. But we want to definitely make that a better first-class experience in the platform itself instead of making our users have to do that themselves. Providing metrics is really nice. So when you see that in Beanstalk and when you see Heroku put those log metrics in the, for you right in your log file of what your application metrics are, you want that as a feature. And so we need to do that too. The good news is we're working on that, so come to my roadmap presentation tomorrow and hear about that. And then the zero downtime updates are something that was really nice in some of the platforms. So when things like what Heroku does when you're restarting their app and they hold your request at the router, or when you're updating your application and they do it one instance at a time so that you don't have to orchestrate it yourself. You can do that with orchestration today with Cloud Foundry. Deploy a version of your app and deploy a B version of your app at the same time and then move the traffic over. But you have to do some scripting for that. And so to make it a first-class feature. So as you can see, like my approach is much more subjective and it's about using the platform, and then Max's much more giving it a scorecard across a whole range of features, and hopefully you got a feel for the differences here. And I'll turn it back over to you for the sum it up.
Yeah, we'll finish quickly. So basically, it's hard to do this kind of comparison. There's obviously a lot of interest because you're here, but it's hard to do it. But there's value. So maybe at some point we can look what to do. A lot of those features eventually become supported in all of them. Having done this multiple times over the years, what I've seen is there was dominant PaaS, and then they kind of copy on each other. So this is the kind of thing that's ongoing. AWS at this point, certainly very mature. It makes sense, to some extent. It brings the question, should we build like a benchmark for PaaS? Some people have talked about performance benchmark, but some kind of a benchmark for features. And then, of course, it would be things like having a common set of apps, allowing these apps to be tested openly so that you get multiple feedback. That may be something we can do. Certainly the spreadsheet, we could make it open source so that other people could contribute to the data. So we could have better statistical sampling of it, crowdsourcing the ratings, and involving other people such as yourselves, right? And iterate over this. So next steps, very briefly, socializing this, the quality of experience, scenario that James went through, having this be something that other people could go through so that we could get other quality of experience.
I do plan on publishing the matrix that I made and the notes that I made.
We'll do the same too.
This presentation.
Yeah, everything else. So with that, we thank you, and I think we may have 1 or 2 minutes for questions. Okay.
There's a bunch over there.
Cost? No. Partly because, I guess we just didn't get to it, but also it varies a lot. Like Amazon changes their costs all the time. But this is a good point. I mean, we could probably do it at one point in time. These are the costs compared. On the back?
Yeah. So the comment is looking at other dimensions besides just the feature matrix or developer user experience. What about the operator experience, being able to update the platforms and evolve them over time? It's a good point.
Yeah, thank you. Anything from this side? Yeah. So the question is whether or not we did an effort to look at the security aspects. we did have this, and what we found is that it's an area none of the PaaS platform right now are sort of dominating. Most of them are very basic. I know at IBM, for a lot of our cloud platforms, we looked at having automated agents that go through and then run a series of tests for security, looking at ports, looking at, none of them do this. And I don't know if we're doing this yet on Bluemix, but that's certainly an opportunity. Maybe last questions? Yeah.
The question is about interoperability between PaaSes. From using them, I can tell you that they're very not interoperable. Almost every single PaaS has a different, like, I'll show you, when I publish the spreadsheet, I ask a simple question. Can I bring a WAR file to the PaaS? Like, how do you onboard your application? Almost every single one was different. Some force you use Git, some of them make you use Maven and Git together. Some of them you can bring the WAR file but through the web interface, but not through a CLI. So it's very fragmented on how you get on. Now, there have been some people interested in things like CAMP, which is an OASIS standard of people trying to bring common platform APIs to these kinds of things. I'm not so sure that that's that great of an effort either, and because if you think about the application, like what I really like about the platform is bring a WAR file. That's as a job. That's my unit of currency. I created a WAR file, go run it, and and outside of that, all these things are very different. So I think there's a constrained set of things you might want to be the same, but then the platforms are so different about how they scale, whether they use containers or VMs, what kind of load balancing they use. They're just how they bind to services. It would be very difficult to come up with an interoperable thing that worked across all of them.
Yeah.